Hello, my amazing students. This is Mrs. A, and I love math. Today, we're doing lesson 22, which is all about multiplying and dividing fractions. So, we're not only going to study how to multiply and divide fractions, but we're going to study a little bit about the concepts that we need to understand when we're looking at our answers to see if they're correct or not. Okay, so here in your book, they show you actual pictures of a gallon and a quart and a pint. And then they make a statement. They say 1 pint is half of a quarter of a gallon. Okay, so a quarter of a gallon we know is a quart, and a pint is half of a quart. So that's what they're saying there. A pint is 1/2 of a quarter of a gallon. So then when we say 1/2 of a quarter, that's the same as 1/2 times 1/4 or 1/4. And remember, when we're multiplying, we multiply the two numerators to get the new numerator and the two denominators to get the new denominator. Now, another thing I want you to think about is 1/2. All right, think of a pizza. 1/2 is half of a pizza. 1/4, picture a fourth of a pizza. How big is 1/8? It is smaller than either the half or the quarter. Okay, so I want you to think about this. 1/8, we multiplied 1/2 and 1/4 together, and we got 1/8. But 1/8 is less than either one of the factors that were multiplied together. So do you mean that you're telling me that when you multiply fractions less than 1, can you finish the sentence? When you multiply fractions less than 1, your product, which is another name for your answer of multiplication, right? Your product is actually smaller than the fractions that you multiplied together. So now we're going to see some pictures of this. Okay, so the first thing we're going to do is what they've shown you in your book. We're going to show you an area model, and we're going to be making some of these area models, okay? Now, the first thing they want us to learn how to do is 1/2 times 1/2. And they're wanting us to recognize that when we're talking about the area of a square, it is length times width, or side times side in a square, right? So area is side times side in a square, or length times width in a rectangle. So the area of what I have here, since I haven't broken it up, is 1 inch by 1 inch. And when I multiply 1 times 1, I get 1 square inches. So the area of this whole big thing would be 1 square inch. But now I'm going to look and model 1/2 times 1/2. So if this is 1 inch, then I'm going to cut this in half. And this over here is 1/2 inch. Okay, and then I'm going to cut this in half. And then that makes this right here 1/2 inch. Okay, so 1/2 times 1/2 would be the area. And 1/2 times 1/2, remember we multiply the numerators and then we multiply the denominators, we get 1/4 square inch. Now, would you not agree that this is, if the whole thing was 1 square inch, like we just said, then this part right here, which winds up being 1/4 of this whole square inch, is going to be 1/4 or 1/4 square inch. Can you see that 1/4 of it is shaded? Okay, so now we're going to look at another one that we're going to model the 1/2 times 1/4. Okay, so this is not one that's done for you in the book, but we're going to model it using our square inch here. And this was the 1/2 of a fourth of a gallon was where we got that one. Okay, so we're going to model the 1/2 by dividing and making this 1/2 inch. Okay, and then we need 1/4 of an inch going the other direction. So I'm going to divide in half and again in 1/4. Okay, so now this right here is 1/4 inch. Okay, so I'm making the fractions that I want. Up here is 1/2 of an inch, and here is 1/4 of an inch. So 1/2 of an inch times 1/4 of an inch will be this area right there, okay? And 1/2 times 1/4, as we saw before, is 1/8. And don't you think that the part that I have shaded in is 1 out of 8 of the, pretend they're equally, they're all equal pieces there. It's not very equal when I haven't measured them out, right? But looks like 1/8, doesn't it? 1/2 times 1/4 is 1/8, and it does look like 1/8 when you do an area diagram like that. Now, we're going to do something a little bit different for our examples. I have been grading your notes, and some of you are doing an excellent job, but not all of you. So now I'm going to start grading your notes the day that you take them. So I'm going to be walking around the room, and I'm going to be checking to see if you are writing the notes down and doing exactly what I'm doing on the video screen. So starting with example 1, if you haven't written everything down up until this point, now's the time. Example 1, we're starting. Get your paper, make sure you number them correctly, write example 1, and then you do everything on the paper, because I'm wanting your paper to look exactly like my board does when I finish with the example. So you're going to be doing everything with me on the board, okay? And you're going to get a grade for this piece of paper, and you're going to turn it in to me at the end of the class day, and I'm going to turn it back to you the next class. So I'm going to grade it just like your homework. Now, maybe I'll turn it back to you right at the end of the class so that you can have it to do your homework. So I'm going to actually be grading it. I might just grade it in your notebook and not even take it up. I'm revising as I go, okay? But I'm going to grade it as I go, and I'm going to put a grade on it, and then after I put a grade on it, it's going to be yours to use to do your homework and keep in your notebook for your notebook check. Okay, so here we go. In example 1, the first one that you must have on your sheet is multiply 1/3 and 2/3 together. Okay, so we're going to do this first, just fraction multiplication. 1/3 times 2/3. Okay, when I'm multiplying, I put a little times sign in between there. And I'm going to multiply the numerators. 1 times 2 is 2. 3 times 3 is 9. Okay, so we know 2/9 is what we're going to see on this area diagram that we're about to do. Okay, so I'm going to go back over here, and I'm going to take one of my other nice little area diagrams, and I'm going to erase everything that was there except for the 1 inch, 1 inch, 1 inch, 1 inch. Okay, we're back to 1 inch, 1 inch, 1 inch, 1 inch. And now it says multiply 1/3 times 2/3. So in order to do this with an area diagram with our 1-inch square, we're going to say, okay, I want to model 1/3 this direction, and then I'm going to come over here and model 2/3 on the sides, okay? So I'm going to look and say, well, I'm going to divide this into thirds, and I'm going to draw a third down and a third down that way. Okay, in a perfect world, there, that's a little better. Okay, so 1/3, 1/3, 1/3. Now, what I'm going to do, over here, it's supposed to be 2/3. But 2/3 is 2/3. It's 2 1/3 put together. So I'm going to go ahead and do the same thing on the other side, just to make it a little bit easier for me to see it. Okay, now I'm going to show you another way that you can do this that may make it a little bit easier for you. Okay, when you're doing 1/3 times 2/3, you can take 1/3 going one direction. So I'm going to take 1/3 and I'm going to say 1/3 of this side. Okay, now I'm going to take 2/3 of this side over here. So 2/3 of this side is going to be going this direction. See, there's 2/3. There's 2/3 right there. There's 1/3 we're not going to take. 2/3. And I'm going to go all the way across with 2/3. And then you're going to see the part where the two cross over each other. So here I just have horizontal lines. Here I just have vertical lines. But can you see right here that I have lines going both ways because they intersected each other? That is your solution. So this right here is your product. Okay, and you could have done that with the other ones that we have done too. I'm just showing you a little bit different way than the book does. When you're doing your model, you can take 1/3 of the square going this direction and then 2/3 of the square going the other direction, and look for where they intersect each other. And that right there is your solution. So we can make our solution. That is the 2/3, and all the rest of this is, we can just make it a little bit lighter because that's our solution right there. Isn't that cool? It's kind of fun too. Okay, so here we have example 2. So I hope you have your pencils ready. We're going to multiply 3/4 of 8/9. 3/4 times 8/9. Okay, now when we're doing this, we're going to cancel. Now you've had canceling before, but you may have forgotten how to do it well. So we're going to reteach you how to cancel. When we're canceling, we want to look at any numerator with any denominator. I do not have to use the denominator that's right underneath the 3. I can go over here and use this 9. And I could say, 3 and 9 have a factor in common. There is a 3 inside of the 9. So if I look at 3 and I divide it by 3, I would get 1. If I divide this one by 3, I would get 3. I divided both the numerator and the denominator by the same number. So basically, I divided the whole fraction by 1, so it doesn't make a difference. But that 1 was a 3 over a 3. Now, I'm going to do it again. I'm going to divide the whole fraction by 4 over 4. I'm going to divide the 8 by 4 to get a 2. I'm going to divide the denominator by 4 to get a 1. I divided by 4 over 4, but 4 over 4 is 1. So I'm good, right? So now I'm ready to multiply. 1 times 2 is 2. 1 times 3 is 3. So the answer is 2/3. And we got it pretty easily. Now let's go back and think what would happen. 3 times 8 if we didn't cancel. 3 times 8 is 24. 4 times 9 is 36. Now, if I wanted to, couldn't I divide both 24 and 36 by 12? Okay, so 24 divided by 12 is 2, and 36 divided by 12 is 3. I'm going to do it this way. That way's faster and easier, isn't it? Okay, so that is canceling, and we're going to be practicing that quite a lot. Okay, now, example 3 has something to do with reciprocals and multiplicative inverses. Okay, so everybody get example 3 ready. So up above example 3, it tells you that a reciprocal is what you multiply one fraction by its reciprocal to get 1. So a fraction times its reciprocal is 1. Or as your book says it, if the product of two fractions is 1, then the two fractions are reciprocals. Okay, and reciprocal is another name, has another name. It's called a multiplicative inverse. Okay, and so we're going to use reciprocals in a little bit to help us divide fractions, but reciprocals are very handy. So here it says, what is the reciprocal of 5/6? Well, we know that a reciprocal times a number times its reciprocal must be 1. Okay, so if we flip 5/6 over and we multiply, wouldn't we get 1? We have 5, 6 times 6 fifths. 5 times 6 is 30. 6 times 5 is 30. 30 divided by 30 is 1. Okay, so the reciprocal of a fraction is just the number, the fraction itself flipped over upside down. Multiply, what was the multiplicative inverse of 3? Okay, now 3 is a little tricky because it's a whole number, but we can always flip a number after we stick it over 1. Okay, so that's the hint, that's the trick. If you have 3 and you want to find its multiplicative inverse, which is the same as its reciprocal, you put a 1 underneath it. 3 over 1 is the same as 3. And then you flip it over and you get 1/3. So the multiplicative inverse of 3 is 1/3. I should have left myself a little bit more room there. Okay. Now C says, how many fourths are in 1? Okay, well, we've had pictures of fourths, haven't we? So if we said, here was our square. Okay, our square is 1. There's our fourth. How many fourths are in 1? 1, 2, 3 fourths are in 1. So the answer is 4. We can reason that out. There are 4 fourths in 1. But if I were going to ask you how many 2s there are in 10, what would you do? You would divide 10 by 2, and you would say, oh, there's 5 2s in a 10, wouldn't you? Okay, so if I'm going to say how many fourths are there in 1, I would say 1/4. I'd say 1 divided by 1/4. Okay. How are we going to do that problem? Okay, well, when we are trying to divide by a fraction, we do that by multiplying by a reciprocal. So 1 divided by 1/4 is the same thing as 1 times the reciprocal, which is 4/1. So 1 times 4 is 4, and that's what we intuitively knew was the answer anyway. Okay, so when we divide by a fraction, that is the same thing as multiplying by its reciprocal. Pretty cool, huh? Okay, so the fourth question on example 3 says, how many 2/3 are in 1? Okay, how many 2/3 are in 1? So we could take 1 and divide it by 2/3. And when we do, we're going to say, okay, division by a fraction is the same thing as multiplication by its reciprocal. So we take the 2/3, we flip it upside down, and we get 3/2. 1 times 3/2 is 3/2. But 3/2 is improper. It's really, when we simplify it, 1 1/2. So there are 1 1/2 2/3 in 1. Okay, so let's talk a little bit about this division by a fraction. This is not one of the examples, so you're going to write it down as the teaching in between the examples, okay? So it says, what is 2 divided by 3/4? Okay, so 2 divided by 3/4 is the teaching that they're doing in between example 3 and 4, and I want to see it on your notes. Okay, so 2 divided by 3/4, what is the little jingle I'm going to try to get you to memorize? Dividing by a fraction is multiplying by its reciprocal. Dividing by a fraction is multiplying by the fraction's reciprocal. So 3/4 flipped over is 4/3. So 2 times 4/3 is exactly the same thing as 2 divided by 3/4. Well, 2 times 4/3, we need a little help with that. Remember, anytime we're multiplying a whole number by a fraction, we can easily just put the whole number over 1 as the denominator. 2 times 4 is 8. 1 times 3 is 3. 8/3 is the answer, but 8/3 is improper. So what are we going to do now? 8 divided by 3 goes 2 whole times, and 2/3 left over. 2 2/3 is 2 divided by 3/4. Okay, now this is example 4. So hopefully you've copied everything up to this point, and we're on example 4. Example 4 says a quart is 1/4 of a gallon, and a pint is 1/8 of a gallon. How many eighths are in a quarter? Okay, now if you're going to try to find out how many eighths are in a quarter, aren't you going to start with 1/4 and divide by 1/8? How many eighths are in this one? How many of these is in that? Okay, so we're going to divide 1/4 divided by 1/8. So what do we know? Division by a fraction is the same thing as multiplication by the reciprocal. So let's do that over here on a little bit cleaner board. 1/4 divided by 1/8 tells us how many eighths are in a fourth. Okay, but we're not going to divide. We're going to multiply by the reciprocal. So here's our fraction. Our reciprocal is the fraction flipped over, 8/1. Now remember, when we multiply two reciprocals together, a number and its reciprocal, then we always get 1. That's the definition of reciprocal. So we're going to change it to multiplication because we're using the reciprocal. 1/4 times 8 over 1. Now, let's do this one two ways. Let's go ahead and cancel. We're going to cancel 8 on the top. Divide by 4 is 2. Divide by 4 is 1. And we end up with 1 times 2 is 2. 1 times 1 is 1. 2 over 1 is 2. That's one way we could do it. Okay. Or we could have not canceled, and we would have said 8 over 4 times 1 is 4. 8 divided by 4 is 2. Which way is easier for you? Canceling is usually easy because it doesn't require much multiplication. It really does simplify as you go. All right. So, the answer to example 4 is 2. But do I just want to see a 2 there, or do I want to see all of this work? I want to see all of the work. Okay? All of it. Our last example, and then we're going to start our practice problems, which you will then be doing those in your workbook pages. Okay? So, we have 3/4 divided by 1/3. Example 5. So when we divide by a fraction, instead we're going to multiply by its reciprocal because multiplication is easier. All right, so we're going to take the fraction. We're going to flip it over. Remember, that's called a reciprocal or a multiplicative inverse. Okay, so we have 3/4 does not change, but we do change from division to multiplication. Makes it so much easier. So now we have 3 times 3 is 9. 4 times 1 is 4. 9 divided by 4. Okay, now if anybody is having trouble simplifying, 9 divided by 4. 4 goes into 9 2 whole times. 2 times 4 is 8. And we have 1 left over. So the answer is 2 and 1/4. 2 and 1/4. So you will usually see me say 9 divided by 4 goes 2 times with 1 left over, 1/4. Okay, so now it is time to do our practice problem A, which says, where is A? Oops, I flipped my page. A says multiply 1/4 and 1/2. 1/4, and so we're going to put it times 1/2. Use an area model to illustrate the multiplication. So 1/4 times 1/2 is going to be 1 times 1 is 1. 4 times 2 is 8. So the answer is 1/8. So let's go ahead and show an area model of 1/8. So we'll start with our square inch. Whoa, that's not a very square inch. Let me look at it a little bit better there. Okay, we're going to pretend that's a good square inch. Okay, now we're going to 1/4 times 1/2. Okay, so we can do it the way the book does it, or we can do it. So basically the book would say divide the top into fourths. Take one of these fourths, okay, and then divide this side into halves. Take one of these halves and make it a rectangle, and that would be your answer, okay? And that's true. Now, what I like to do, because I think it's more fun, is we're going to take 1/4 and we're going to, okay, remember what this looks like. It's 1/2, 1/4. Okay, so what I like to do is take 1/4 of this side, okay? So 1, 2, 3, 4. So that's 1/4 of this side, and we can shade it Okay, now we're going to take a half of this side and we're going to shade it the other way. Those of you who like to color will have fun with this. I like to color. Now you can see the part that's the same thing that I just showed you a minute ago. This part that has the diagonal going both ways, this is your answer area, isn't it? Okay, so whether you do it the book's way or this way, they're both correct. Have fun with it. Okay, so we're on B, and it says 1/2 of the students in the class are boys. 1/3 of the boys walk to school. Boys who walk to school are what fraction of the students in the class? Okay, so this is what you're looking for. 1/2 are boys. 1/2 of the students are boys. 1/3 of the boys walk to school. Okay, so we're looking at what fraction of the entire student body are the boys who walk. Okay, so first of all, we need to find out what is the fraction of the boys who walk, because the student body is the whole. They didn't tell us how many students there were. So we're just really putting this whole thing over 1, right? So we don't need to have a fraction at all. This, when we find the boys that walk, will create the fraction that we need. So what I'm going to do is, that's just kind of interpreting the problem for you. So we have 1/2 are boys, and 1/3 of those 1/2. So we're going to have times 1/3. Okay, so remember, of is always multiplication. So 1/2 times 1/3. 1 times 1 is 1. 2 times 3 is 6. The boys that walk are 1/6 of the whole student body. That was pretty easy, wasn't it? Sometimes it's just hard to interpret the problem. Okay, so now we're looking at C. And C has no words. It's kind of fun when it has no words. What is 1/2 times 3/4? Okay, so 1/2 times 3/4. There's nothing that's going to cancel on this one, because 3 does not cancel 2 or 4. So we're just going to multiply straight across. 1 times 3 is 3. 2 times 4 is 8. The answer is 3/8. Okay, here is D for your workbook. Okay, on this one, I want you to try to cancel, because 2 and 3 have a common factor of 2. So we're basically, since 5 and 3 don't have any common factors, we're just going to look at 2 and 6. All right, they both have a 2, so I'm going to divide this one by a 2, this one by a 2, and now I'm ready to multiply. 5 times 1 is 5. 3 times 3 is 9. And 5/6 times 2/3 is 5/9. E says, what number is 1/2 of 3/4? 1/2 of 3/4 is 1/2 times 3/4. Again, in this one, there is nothing to cancel, because 3 does not cancel either one, okay? And this one is the same that we did in C. Okay, so this is exactly what we just did in C. So 1 times 3 is 3. 2 times 4 is 8. I don't want just 3/8. I want to see your work on these problems. Okay, I want to see your work. F. Okay, what number is 2/3 of 3/4? 2/3 times 3/4 equals. Okay, can you see something easy to cancel? There are 2 cancellations, but 3 and 3 is very simple, because I'm just dividing the top and the bottom of this answer by 3, okay? And I'm dividing the top and the bottom of the whole result by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now let's multiply what we have left. 1 times 1 is 1. 1 times 2 is 2. Okay? So when you multiply them together, you get 1/2. All right. Oh, this one's fun. G and H says, write the multiplicative inverse, which is the same thing as the reciprocal, for each one of these numbers. Okay, remember, the reciprocal is just flipping over the number. 3/8 will flip over to be 8/3. Okay, but now it's improper. So 8 divided by 3 goes 2 whole times, and then I would have 6, and I have 2 left over, so 2/3. 8 divided by 3 goes 2. 2 times 3 is 6. 8 minus 6 is 2. 2/3. Okay, so we'll get rid of that. And the reciprocal of 4 is 1/4, because even though that's a whole number, it is 4 over 1. I flip it over and it becomes 1/4. That is G and H for you. Okay, I says, how many 2/3 are in 1? How many 2/3 are in 1? So we're doing 1 divided by 2/3, which is, remember, division by a fraction is multiplication by its reciprocal. So it's going to be 1 times 3/2. Well, 1 times anything, you get the same number. So 1 times 3/2 is 3/2. That's an improper fraction. So 3 divided by 2 is 1 time with 1 left over. So we're going to have 1 and 1/2. Okay, and J says 1 divided by 3/5. Well, 1 divided by 3/5, division by fraction is multiplication by its reciprocal. The reciprocal of 3/5 is 5/3 times 1. So I change the division to multiplication. I flip over the fraction. 1 times 5/3 is 5/3. 1 times 5/3 is 5/3. 1 divided by 1/6. Well, I flip the 1/6 over to get 6 over 1. Change the division to times and put the 1 in there. 1 times 6 over 1 is 6. 1 times 6 is 6. The answer is 6. Okay, and, okay, so we're on L now. L says, how many 1/2 are in 3/4? And they even give you a hint in the book. 3/4 divided by 1/2. So we're going to leave the 3/4 alone. We're going to change the division sign into a times. We're going to flip the 2 over to get 2 over 1. And it's as easy as that. Okay, now nothing, well, the 2 and the 4 will cancel, right? I divide this by 2. I divide this by 2. 3 times 1 is 3. 2 times 1 is 2. The answer is 3/2, but that is improper. So we will change it to 3 divided by 2 is 1 with 1 left over. So 1 and 1/2 is the same thing as 3/2, but it is the preferred answer. 1 and 1/2. Okay, so LM. M just gives us 2 fractions divided. 2/3 divided by 3/4. Okay, now, don't get fooled. You say, oh, I can cancel. You can't cancel yet because that's division. So we're going to say 2/3 times, flip this one over, 4/3. Okay, so now nothing cancels. 2 times 4 is 8. 3 times 3 is 9. And the answer is 8/9. And this is our last practice, and then we're going to do a few problems. Okay, 3/4 divided by 2/3. So what are we going to do? We're going to take 3/4, leave it alone, change the division to a times, flip over the fraction at the end, 3/2. Nothing's going to cancel, is it? All right, so 3 times 3 is 9. 4 times 2 is 8. 9 divided by 8 is 1 whole time with 1 left over. So it's 1 1/8 times. So now we're ready to go on to some of your problems. Number 1 is a word problem. Okay, Mariah ran 14 miles in 1 week. So 14 miles. And at that rate, how many miles could she run in 5 days? So if she ran 14 miles in 1 week, how many miles in 5 days? Okay, so let's think about this. It's kind of hard to think about days and weeks. We don't want two different denominators, do we? We'd rather get one like denominator. So why don't we get smart and change our week to 7 days? Ah, there we go. 14 miles in 7 days. So how many miles is Mariah going every day? Well, 14 divided by 7 is 2 miles per day. 2 miles per day. Okay, if she's going 2 miles per day, that means 2 miles every day. How far does she go in 5 days? Okay, so 1 day is 2 miles. 5 days would be 10 miles. Okay, now we can reason it out like that, but I'm going to show you another way to do it with our conversion factors, because I'm trying to get you to use your conversion factors. Okay, 14 miles in 1 week. And we want to know how far she can run in 5 days. How far can she run in 5 days? Okay, so now let's look at this. We have 1 week on the bottom. When we get done, we want 5 days on the bottom. Let's see if we can get there. Let's see if we can kind of reason this out. So I'm going to multiply by a conversion factor that's going to change me from weeks to days. So I'm going to say, well, I know that there's 1 week in 7 days. Or would it be 7 days, 1 week? Okay, where are we trying to go? We're trying to get down here to 5 days on the bottom. So I think we should use this one. Now, they're both exactly correct, but we have to decide which one we need for our situation. So we're going to multiply by 1 week over 7 days, because we want weeks to go away. We want to cancel it. So 1 week, 7 days. Okay, so I'm going to get rid of all of that. Okay, so now, what do I have? I have 14. Okay, so miles does not cancel anything. 1 week cancels 1 week. And we're going to be left with miles per day. Okay, so can we go ahead and cancel 14 and 7? 14 and 7 both have a 7. So 14 divided by 7 is 2. 7 divided by 7 is 1. So we wind up getting 2 miles, because all of this cancels, over 7 days. No, 1 day. 1 day. Now, could we just multiply by, we have 1 day, we want 5 days. Could we multiply by 5 over 5, which is 1 and doesn't change anything? 2 miles times 5 is 10 miles in 5 days. And the answer is 10 miles. Okay, so that one was number 1. So now let's do, so did anybody need to see that more, a little bit longer, so you could get all that work down? Okay, so let's go ahead and do number 2, which is a really long word problem. Okay, so number 2 says, the triathlete swam 2 miles in 56 minutes. Okay, then he rode his bicycle 100 miles in 5 hours. Finally, he ran 20 miles in 160 minutes. Boy, I'm tired. 160 minutes. Okay. How many minutes did it take him to complete the course? So how many total overall minutes? And during which portion of the race did he have the greatest average speed? Okay, so this is our information. 2 miles in 56 minutes. That was swimming. Okay. 100 miles in 5 hours, and that was his bicycling. And 20 miles in 160 minutes. So they had minutes, hours, minutes. Okay, now we're supposed to find out how many minutes altogether. So I think we really would do best if we changed our 5 hours to minutes right away, because everything else is minutes. So let's be consistent so that we can see where also he had the greatest speed. Okay, so we're going to change 5 hours. We know that there are 60 minutes in an hour. So 5 times 60 would be 300 minutes. 300 minutes. Okay, so now everything else is going to be miles per minute, miles per minute, miles per minute, and minutes. So if we're going to find the total amount of time that he spent in the whole race, aren't we just going to add 56 and 300 and 160? We don't want to do any simplifying, do we? Because he was swimming for 56 minutes, and he was on the bike for 300 minutes, and he was running on his feet for 160 minutes. So we want to find total number of minutes. We're going to add 56 plus 300 plus 160. So 300 and 160 is 460. That's pretty easy. 460 plus 56. So total minutes was 516 minutes. Wow, 516 minutes. Okay, so that was the answer to the first part. 516 minutes. Now, how can we tell which one of these is faster? So we have 2 miles in 56 minutes, 100 miles in 300 minutes, and 200 miles in 160 minutes. Now, when we're trying to figure out speed, aren't we used to having the denominator 1? Okay, so if we want to have the denominator 1, then we're going to basically take the numerator and the denominator and simplify them to get whatever fraction. Now, on this one, what I would do is probably turn everything into a decimal if you wanted to, because then you wouldn't have any problem figuring it out. Okay, so 2 over 56 is a fraction that will reduce to 1 over 28. I'm going to just do it to fractions, though, because I can do that in my head. Okay, so 1 over 28, 1/3. Remember, your zeros are going to cancel out. 1/3. Okay, so this is going to work because all of our numerators are 1. So we'll be able to tell which one's the largest, won't we? 20 over 160, the zeros will cancel. And 2 divided by 16 is 1 divided by 8. All right, so we did it in fractions instead of decimals because it was easier. I didn't have to get out a calculator. Now, remember, the larger the denominator, when the numerator is all the same, the larger the denominator, the smaller the quantity. So it does make sense that he's moving the slowest when he is swimming. 1 over 28 is much smaller than 1/8 or 1/3. So he's moving the fastest when? What is his fastest speed? 1/3 is bigger than 1/8. Think about a pizza. Do you want 1/3 of a pizza or 1/8 of a pizza? Do you want to split that pizza with 3 people or with 8 people or with 28 people? I'm taking the 1/3 of the pizza, right? Okay, so that one was a fun problem. Okay, number 3 says expand 3 times x plus 7. Okay, so we're going to distribute, aren't we? 3 times x is 3x. 3 times 7 is 21. 3x plus 21 is your expanded form. This 3 times the parenthesis, x plus 7, is your factored form, and this down here is the expanded form. So next, number 4, they tell us to factor a form. I'm trying to keep the light out of there. Okay, so 5x plus 35. Now we're going to factor, which is the opposite of expansion. So we're going to look at 5x and 35 and say, what do they have in common? They both have a 5. So I'm going to pull the 5 to the front. So then I'm going to say, well, 5x divided by 5 is x. 35 divided by 5 is 7. 5 times x plus 7 is the factored form. To check it, I distribute it. 5 times x is 5x. 5 times 7 is 35. And it's correct. Number 5 says, what is 6 plus 4 over 7 minus 2? Now, this is an order of operations problem. Remember when we were in order of operations, division takes precedence over addition and subtraction. But division was also used as a grouping symbol. So basically, this numerator, that's just the number 5 for the problem here. This numerator is divided by this denominator. We would never separate them. Okay, so in this case, the numerator is considered a grouping and the denominator is considered a grouping. And this division sign across the middle is saying they are separate from one another. So we are, in this case, going to add the numerator together, add the denominator together, and then divide. Okay, 6 plus 4 is 10. 7 minus 2 is 5. So anytime you have a big fraction that has a lot of stuff on the top and a lot of stuff on the bottom, you will always figure out what the numerator equals, figure out what the denominator equals, and then divide. But now, I haven't finished because 10 divided by 5 is 2. So I should always simplify. That was number 5. Number 6 says, oh, it's long, okay? It says 6 plus, this is number 6, 6 plus 5 times 4 minus 3 plus 2 divided by 1. Okay? 6 plus 5 times 4 minus 3 plus 2 divided by 1. Yep, that looks like what it says. Okay, so here we go. What does our order of operations say? Please excuse my dear Aunt Sally. I don't have any parentheses, brackets, braces, absolute value. All of those are grouping symbols. I do not have any powers or exponents. So I'm going to jump right into multiplication and division as we see them left to right. Multiplication, division, as we see them left to right. 5 times 4 is 20. 2 divided by 1 is 2. Now let's write them. 6 plus 20 minus 3 plus 2. Now I'm going to go left to right. 6 plus 20 is 26. 26 minus 3 is 23. Plus 2 is 25. 25 is our answer. 25 is our answer. Okay, so notice how I went to times, division, got those simplified, wrote it again, and then I went left to right until I figured out what my answer was. So there is number 6. And we are done. I've done all of your practice problems. I've done all 6 of your starting problems. So you have 24 problems left. So turn in your notes to me real quickly to get your notes graded. You should have on your notes 5 examples. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically your 5 examples, and then on your worksheet, all of your practice and all 6 of your first 6 problems. And we're done. This is Mrs. A, and may God bless your day.